Great.
Yeah.
Thank you, everyone. Thank you so much for joining. Oh, that's a good list of participants out there for a Sunday afternoon. We have 60 participants out there, and without much overdue, let's get it started with a quick introductory video.
हे दोस्तों, वेलकम टू अपना कम्युनिटी। ये वो जगह है जहां आप अपने असली पोटेंशियल को एक्सप्लोर कर सकते हैं। देखो, सबके पास स्किल्स होते हैं, पर क्या आपके अंदर वो स्पार्क है जो आपको कामयाबी की ऊंचाइयों तक ले जा सकता है? अगर आप सोच रहे हैं जॉब चेंज करने के लिए, लेकिन रेज्यूमे सेलेक्ट नहीं हो रहा, या फिर इंग्लिश में इंटरव्यू देना थोड़ा चैलेंजिंग लग रहा है, तो फिक्र मत कीजिए। यहाँ हम हैं आपके साथ, आपको सपोर्ट करने के लिए। अपना कम्युनिटी में आपको मिलेगी बेहतरीन कम्युनिटीज, जहां आप अपने प्रोफेशनल स्किल्स को सुधार सकते हैं। चाहे आप एक्सेल, टैली, जीएसटी में माहिर बनना चाहें, या फिर आप खुद एक ब्यूटिशियन या डिजाइनर हैं, तो यहाँ आप अपने काम को शोकेस करके दूसरों को टिप्स एंड ट्रिक्स देते हुए आगे बढ़ सकते हैं। अपना कम्युनिटी में आपको मिलेगा मेंटर्स का एक खजाना और बड़े इन्फ्लुएंसर्स का साथ, जो आपको हर कदम पर 1-to-1 गाइड करेंगे। यहाँ आप ज्वाइन कर सकते हैं अपने फील्ड या इंडस्ट्री स्पेसिफिक ग्रुप्स, जहां आपको ऐसे कई लोग मिलेंगे जिनसे सीख के आप वो गलती ना करें जो वो कर चुके हैं। ऐसे लोगों की जिन्होंने स्टार्ट किया था एज एग्जीक्यूटिव्स एंड आर नाउ सक्सेसफुल मैनेजर्स इन देयर डोमेन्स, जो आपको आगे बढ़ाने में मदद करेगा। यहाँ आपको मिलेगा वो सही डायरेक्शन जो आपके करियर को नेक्स्ट लेवल ले जाएगा। तो लेट्स अनलॉक योर पोटेंशियल टुगेदर। अपना कम्युनिटी में ज्वाइन करें और अपने सपनों की ऊंचाइयों तक पहुंचने का सफर शुरू करें।
Are you serious? I'm an assistant manager for HSBC, and then I work for IBM, and you're talking in Hindi. Speaking in Hindi, I'm sorry.
Sorry, Neeraj, that was an introductory video, and we are going to start off the session in English in case
Please
you
do
are just,
so in English.
I think you are quite early. Just wait for us to even start introducing, and then you can take up questions.
Yeah.
And I would appreciate if you go on mute because it's disturbing introductions. Anyway, thank you,
Yes.
thank you so much, guys.
One
Thank
second.
you for
One
joining.
second.
Thank you for joining on a Sunday. We have a full house. We have about 70 people joining. And my name is Rohan, one of the co-founders of QFUS, handling the Apna Exclusives here. QFUS is basically a mentorship platform. You can go and check it online. And we have been conducting this Apna Exclusives for quite some time now, for more than a month, where it happens on 3 p.m. on weekends and weekdays at 7 p.m. Main idea is to help people ideate around different topics, professional careers, and covering a wide range of topics, be it functional topics or even spoken English, technology, data science, and so on. And today we have our mentor, Mr. Mary, with us, and he will be taking us through a very interesting topic of data analytics, databases, and SQL. And without much overdue, I will hand it over to Mary. And Mary, it's up to you. The floor is yours.
Yeah,
Thank you,
please.
Rohan.
And we'll take up the questions on the chat box.
Yeah, please do so.
Yeah, could you share the screen sharing for me?
Is he the host? Is Mary the... Okay, I'm just making you the host. Yeah, that's
And I
right.
would request all the participants to please go on mute. We'll have the questions at the end or in between. If you have any questions, please do type it rather than coming unmute, coming yourself unmute and then asking the questions, because it might disturb the flow. So request you to kindly do that. Okay. So please let me know when you can see the screen.
Yes.
I'm not able to see the screen. Unable to see the screen.
Yes, we are able to see the screen, Mary. Please go ahead. In case anyone's not able to just see the screen, request you to disconnect and connect back. Thanks.
Okay. I'm just going to do that. Okay. Yeah.
Okay, so let me get started. So, hey everyone, welcome to this session. Today we will be covering about the basic concepts of data analytics, what is databases, and a bit about SQL. Don't worry about all these terms. I will be trying to explain take you through each of these, make you understand it in layman terms so that you get to know why is the entire world behind the idea of data analytics and all those things. So the agenda for today's session is I'll have a brief introduction, then we'll go into data and analytics, then I'll introduce to RDBMS and SQL, few functions in RDBMS and SQL, then I'll tell you where does data science, A and ML sit, and what is the role of Python and SQL, what is important as you move through the learning career or learning path or the career, and then after this session, what can you do to enhance the learnings that you have got through this particular session, and then later on we'll take the question and I'll give you the answers. I will move into the Q&A. So I'll just give a brief introduction about me. I'm a senior data scientist with Cisco Systems Private Limited, and I have been into the data science, data analytics, big data field for over 11 years now. I started with data warehouse and moved into big data analytics, then got a chance to move into data science, and right now I'm working in machine learning and artificial intelligence domain as said. I worked in different organizations like Nielsen, IBM, and right now I'm in Cisco as a data scientist. And my educational journey is I completed my BTech in computer science engineering from National Institute of Technology, Calicut. I've completed my master's in data science from University of Arizona, and I've completed my master's in machine learning and artificial intelligence from LJMU. All throughout the session, if you need to ask any questions, please use the Q&A session or the chat box, and you can ask me the questions. I'll be more than happy to help you answer. Okay, help to answer that questions. So without much delay, I'll get started with the topics. First one, let's try to understand what data is. Okay, so this will be more of a interactive session. I know everyone might have started their session. Everyone will start their session with this particular term. It should be an interactive session, but I would prefer to get to know what you guys know and then try to build upon that. So let me ask this question. Everyone is into data analytics. Everyone wants to learn data analyst. Everyone wants to be a data analyst, data scientist, etc. What do you mean by data? Can someone explain me what is data? What is data? Anyone can type. You can type in a chat box. Data is raw fact, information, raw information, sort of information, unprocessed information, collection of information. Yep. So data is warehouse of data. Okay, collection of information regarding to a particular field. Okay, so if you see, majority of them, a few of them was bang on with the answer, and majority of them have been using the word information. That is why specifically I started with the term data, and I started asking the question, what is data? Because I wanted to make you understand there is a clear difference between data and information. Okay, let's try to understand what data is and how it is different from information. Any facts, observations, perceptions, numbers, characters or symbols, images, audio, video, etc. are called as data. So few of them were telling data is nothing but raw facts or figures. Correct. That is the exact definition. Now, anything that is a fact, that is an observation, that is a perception, it includes numbers, characters, symbols, or it's an image, audio, video, etc. All that is called as data. Now, the next question that might come to your mind is, if that is a scenario, what is information? Data is not information, but when you process the data, that is where you get information. Okay, so once when you process the data, that is where you get the information out of it. Data is nothing but raw facts and figures. The moment you process it, you get information out of it. Now, let me try to explain this to you. Okay, does these two mean anything to you? There is something written as SK01, B3413, NL07K96. Anything? Does this mean anything to you? Can anyone guess
Yeah.
it?
Hello.
Yes.
Yeah. It just mean like someone the process the data into a machine and
No,
and bring
sorry,
out the
sorry.
insights.
No, my question is, did you understand what this is? SK01B3143, NL07K96. Anyone? No, right? Because this is data. I've just given you data. Now I'll tell you how to process it. The moment you start processing it, you'll get the information out of it. Right? Someone has guessed it. SK stands for Sikkim. 01 stands for Gangtok RTO. B stands for 19,998. And then 23. So 3413 means 19,998 plus 3,413. This means 23,411th vehicle registered in Gangtok RTO of Sikkim. Now, you know that SK01B3413 was raw data. You know how to process it, and then you got the information that this is the vehicle number corresponding to so and so vehicle, right? Now, the moment you see NL07K96, you know that this is nothing but so and so vehicle registered in Dimapur RTO of Nagaland, right? This is the difference between your data and information. Data is nothing but raw facts and figures. The moment you process it, then you get information out of it. Okay, all with me? Any questions? Good job, Keshav. You were able to guess it. I was trying to bring in uncommon states so that no one guesses it, but still, it was good. So you already processed it and then you got the information out of it, right? So that's how data and information differs from each other. From today onwards, if someone asks you what is data, please make sure that you don't tell that data is information. Data is nothing but raw facts and figures. Any numbers, any combination, anything can be data. The moment you process it and you get something out of it, that is what is called as information. Okay, so this was nothing but raw facts and figures. The moment you processed it, you got the information that this is so and so vehicle from so and so particular RTO. Okay, all good with me? Moving on. Now we learned what is data. Now there are different types of data. Data can be categorized into three based on their structure. The first one is called as unstructured data. The second one is called as semi-structured data. And the last one is called as the structured data. So raw facts and figures, when you process it, you get information. And then data based on the structure can be divided into three categories. First category is the unstructured, second one is the semi-structured, and the third one is the structured data. Let's try to understand what each one of them means. Unstructured data. So your unstructured data means it doesn't contain any field, columns, or it doesn't have any structure at all. It, as the name suggests, there is no structure at all. It does not follow any particular format, sequence, semantic, or rule. And it doesn't have any predefined data model. Some of the sources of unstructured data are multimedia files like your audio files, video files, etc. Then your social media files, that your Facebook data, your Twitter data, etc., your documents and PDFs, etc. Now, I'll try to explain it in simple words. Have you ever seen a PDF document or a Word document where you can easily write a rule, or you can tell that every paragraph in that document has 10 sentences? Can you write a rule telling that every sentence in a given line in the Word document has 10 words? No, right? You take a document, your first paragraph may have 10 sentences, your second paragraph may have more than 10 sentences or less than 10 sentences, your first sentence may have 20 words, your second sentence may have less than 20 words or more than 20 words. So there is no predefined rule, there is no predefined structure. Each paragraph, each sentence for that matter, each word would have different number of letters. So there is no predefined structure at all. It keeps on varying. Such data is called as unstructured data. There is no structure at all. You can't tell that every document has only 1,000 words. No. There are documents which have more than 1,000 words. There are documents which have less than 1,000 words. So there is no predefined rule for any of these documents or PDFs. Such data where there is no defined structure, or there's no columns, there's no fields, etc., you call them as the unstructured data. And the most common one that you see on a daily basis, your Word documents, your PDFs, your social media post, your Twitter post, everything is called as unstructured data. Moving on, the next one is the semi-structured data. Okay, semi-structured data is where there is some organizational properties, but it lacks a fixed or rigid schema. Now, it's not stored in the form of rows and columns, but it contains tags or other semantic elements to group or organize it as a hierarchy. Some of the examples are your emails, XML and JSON files. Okay, very simple. I would not take you to XML or JSON files because few of them might have not seen how an XML file or a JSON file might be. Few of them might have seen. So let's take a common one. Everyone might have sent an email, right? Everyone would have an email ID. Everyone might have sent an email. Your email will definitely have a to address, correct? It will have a from address. Then it will have a body, correct? So there are three things. Do we have a structure there? Yes, there is a structure. There is a to field, there is a from field, there is a body. Now, if I take the to field, it could be to multiple people, correct? Or it could be to a single person. So there is no structure there. It could be to multiple people. It could be to single person. From address, from a single person, your body can have 1 paragraph, 2 paragraph, 3 paragraph, 1,000 words, 2,000 words. It could be anything. Now, are you understanding that? There is a structure to it, but that structure is not fixed or rigid. There could be mails where you are not even writing anything in the body. There could be mails where there is an attachment, but there is no body. There could be mails where there is body, but there is no attachment. Is there a structure? Yes, there is a to, from. There could be a to, there could be a from, there could be a body, there could be an attachment. But is it fixed? No, it can change. Your body can change. Your to, the number of to addresses can change. So that is where it is called as semi-structured. Is there a structure? Yes, there is a structure. Is it rigid? Is it followed throughout, everywhere? No. You take two different mails. One mail may have an attachment, the other may not have an attachment. So it's not consistent across. So such data where there are some organizational properties, but it lacks a fixed or rigid schema is called as a semi-structured data. Okay. Now, moving on. And similarly, all those who have seen the JSON file and XML files or JSON files, you might have seen the tag and the body, right? So your tag will help you to organize it, but your body will have, again, varying structure. And there could be a header tag, there could be a subheader tag, there could be a body tag. There could be scenarios where you only have header and body, so and so. So the structure is there, but it's not rigid. Such data is called as semi-structured data. Moving on, let's move to the next one, which is the last one, which is the structured data. This is the most common one, and you might have seen it everywhere. So the structured data is where you have a well-defined structure. Well-defined structure means everything would be in rows and columns. There is a predefined model, and every data will follow that. It is a tabular format where you have rows and columns, and simple examples are your structured SQL DBs databases, or your online transaction processes, or your spreadsheets, which is nothing but your Excel. Okay, all those. If you take an Excel, you take any Excel file given by anyone from any source, your data will have rows and columns, right? You take any Excel file, it will have rows and columns. That is a rigid format. It needs to have columns and it needs to be in rows. Such data where there is a defined structure, and that defined structure is rigid and consistent across all the files that you see of that type. It is called as structured data. Okay, so unstructured data where there is no schema at all. Then you come to semi-structured data where there is a certain organizational property, but it's not rigid as such. And the last one is the structured data where where there is a defined structure and it's consistent across. Okay, you take any Excel file, it will have a row, it will have a column, and there will be values in it. That's how your Excel will be, correct? Okay. Correct. Few of them were telling about data in tabular form, etc. That's all right. Yeah. So that's how it is. So data, raw facts and figures, the moment you process it, you get information out of it. Based on the structure, your data is divided into three categories: your structured data, your semi-structured data, and your unstructured data. And we understood what each means. Okay. Any questions on that? Anyone? I don't see any questions in the chat. I hope everyone is clear with it. Great. Moving on. Next one is we'll try to understand what is data analytics. Now, everyone knows that there is something called as data analytics, etc. But we now understood what is data. Now let's try to understand what is analytics. When you are trying to analyze your business data, okay, through statistics and software, and you get insights and patterns out of it, based on that insights and patterns, if you make better decisions, then it is called as analytics, data analytics. So you have data, you do analysis on that using certain softwares or statistical methods. You figure out insights and patterns. Insights is nothing but information. It's another term for information. Okay, insights and patterns out of your data. And based on that information, if you make better decisions, then that entire process is called as analytics, data analytics. Now let me give you a simple example to make you understood. Okay, make you understand this. Let's say that I'm traveling from a particular A to B. Okay, I'm traveling from A to B, and on the first day I took route 1. Which costed me 100 rupees, and it took me 1.5 hours to reach from A to B. Okay. On the second day, I traveled in another route 2. Again, from A to B, I took another route 2, which costed me 150 rupees, but I reached in 1 hour. Now, on the third day, if I have to travel from A to B, which route should I take? So on the first day, I took route 1, which took me in 1.5 hours and costed me 100 rupees. On the second day, I traveled in route 2, which costed me 150 rupees, but it took me only 1 hour. On the third day, if I am supposed to travel from A to B, which route will I take? Route 2. Any other answers? Route 2. Only Ratika says route 2. Anyone else? No one has an opinion about it. I hope you understood what I'm trying to. Depends on the user. Good one. I would try to modify that answer. Gaurav, that's a good one. I would try to modify that answer, which is I would ask the user, what do you want to achieve here? Whether you want to reach at an early time or whether you want to reach there cheaper. That's where the question is. So, and that is why the last point, better decision, is very important. Okay. Now let me break down that question or that use case for you and make you understand it. I traveled for 2 days. So what did I do first? I analyzed my data and I found out that route 1 cost is 100 rupees, time 1.5 hours. Route 2 cost is 150 rupees, time is 1 hour. Correct? So that is the analysis part, right? Now, using any statistics or software, here the data is not so complicated, so we didn't need any statistics or software. Otherwise, you might have used Excel or something else. Okay. And what is the insight that you got? Route 1 takes more time but is cheaper. Route 2 takes less time but it is costly. Now, On the third day, I could have taken route 1 or route 2. Both are decisions, right? Both are decisions. Going in route 1 is a decision. Going in route 2 is also a decision. But if I want to reach early, which is the better decision? Going in route 2. If I want to reach in a cheaper, which is so that is the whole process of data analytics. I analyzed my data, I got information out of it, and based on my use case, I tried to figure out which is the better decision for me. And that this entire process is called as data analytics. All with me? Simple. Data analytics, I have data, I need to analyze it. When I analyze it, how will I analyze it? Using some software or statistics. After I analyze it, what will I get out of it? I'll get insights, information out of it. Using that information, what will I do? I'll make better decision. Prince, for your question, which software is best? It depends on what data you're working, what you are trying to achieve, etc. Okay, there is no best software as such. There are multiple softwares depending on the use case in hand, depending on the type of data that you're using, the software keeps changing. A simple one is Excel. There could be SQL, there could be R, there could be Python, it could be multiple things. Okay, and a mix of all these things. But all understood, right? What is data analytics? Right? Okay, now next one is something that you might be able to answer. We all understood what is data analytics. There are 4 types of analytics. Can anyone tell what are the different types of analytics? Analytics. I know, I'm pretty sure that one of the analytics is very common and everyone would know that there are different types of analytics. We understood what data analytics is. There are different types of analytics. Does anyone know what are those different types of analytics are? Anyone? Business analyst is a role, but Audrey, that's to a certain extent business analysis. Business analysis doesn't form as a basic type of analytics. Yeah, there we are getting the answers, which is descriptive, prescriptive, predictive. Software is not a type of analytics, but I think you have covered, everyone is familiar with the predictive one, right? Okay, and I see the last one, diagnostic. Now, everyone has given me different answers. So the 4 types of analytics is, the first one is the descriptive analytics. Then you have the diagnostic analytics, you have the predictive, and the last one is the prescriptive. Now, there is a catch to this, which is this has to be in the order, which means that the first thing that you do about a data is descriptive analytics. Descriptive analytics tell you what happened historically, what has been happening. That is what descriptive analytics is. Then only you can do a diagnostic analytics, which is why it happened. So descriptive is what happened, diagnostic is why it happened, predictive is where you are going to tell what will happen, and prescriptive is what should be done about it. So what did I mean by telling you that this has to be in an order? It means that you cannot do a diagnostic analytics without doing a descriptive analytics. You cannot do a predictive analytics without doing a diagnostic analytics, which in turn cannot be done without doing a descriptive analytics. And you cannot do a prescriptive analytics without doing a predictive analytics, which in turn cannot be done without using a diagnostic analytics, which in turn cannot be done without a descriptive analytics. So this has to be in an order. So there are 4 types of analytics, which is descriptive, diagnostic, predictive, and prescriptive. Descriptive helps you know what happened. Diagnostic, why it happened. Predictive, what will happen. And prescriptive, what should be done. Now, I'll give you a simple anecdote to remember this. Okay. Imagine that you are fallen sick. You have some sickness and you are going to visit a doctor. You went to the doctor, and what is the first thing that you do? You give him a description of what you are going through. I'm having cough, I'm having headache, etc. You're trying to describe your problems. You're trying to tell you what has happened over the past few days to you, what is being happening, right? So you give a description of what has happened. Then what does the doctor do? He diagnoses you. He figures out what your disease could be. He's doing a diagnosis on what, based on what has happened, he will diagnose you. Then he will tell you in the coming few days, you might feel more shivering, there will be more cough, etc. What is he doing there? He's trying to predict what is going to happen in the coming few days. And finally, when you're going to leave the doctor's room, he will give you what? He will give you a prescription, right? So descriptive analytics, diagnostic, predictive, and prescriptive. Next time when someone asks you what are the 4 types of analytics, just remember you going to a doctor. What is the first thing that you do? You do a description. You describe to him what you're going through, which is nothing but descriptive analytics. Then he will do a diagnostic analytics. Then he's going to tell you what is going to happen in future. Predictive analytics. And the last one is where he gives you what should be done so that this can be avoided or this can be made better, is what is the prescription, right? Prescriptive analytics. All with me? 4 types of analytics: descriptive, diagnostic, predictive, and prescriptive. All good? Remember, very easy way to remember is going to a doctor. Okay. Descriptive says what happened, diagnostic why it happened, predictive what will happen, and prescriptive is what should be done. Now, in certain blogs or articles, you may see that prescriptive analytics is that analytics which will help you to figure out what should be done to avoid a loss or etc. Now, I wouldn't suggest that you should stick to the definition of what should be done to avoid, because let's say that I look into my business data and I did a prediction, and the prediction says that next year my profit is going to be way better. Will I do something to avoid it? No, I'll try to make it better again, right? So it should be what should be done based on what is the output of your predictive analytics. That is what prescriptive analytics is. Okay, all good. Any questions? So up till now, I'll just do a small recap. Up till now, what we learned is what is data, what is the information, what are the different types of data based on the structure, what is data analytics, what are the different types of data analytics.
Excuse me.
Yes.
Yes. Could you explain me one more time what is the data analytics? I didn't hear.
Sorry, which one you want to know? What is data analytics?
Yeah, data analytics.
Yeah. So again, let's say that you have some data with you. When you analyze that data using some software, some tool, some statistics method, etc., you get information and pattern out of it. And based on that information, you're making some decisions that is very in line with your business, that will make your business better. Then that entire process is called as data analytics. So data analytics, you have data, you analyze the data using some tools or software, and you get information out of it. Using that information, if you make a better decision, then that is what is called as data analytics. Basically, there are 4 types of data analytics, which is descriptive, diagnostic, predictive, and prescriptive.
Yeah, okay, thank you.
The difference, Sukhdeep, hi. The difference between analytics and analysis is that verb. You are doing it. That is what is analysis. That process is called as analytics. Analysis is that physical work. When you do, it's like, how would I come with another example, which is, when you are doing that work is called as analysis. And this process of doing that work is called as analytics, that process. Okay. I hope it's clear.
Yeah.
All right. Next, moving on to the next one, which is, let's see what is the data analytics ecosystem as a whole. So we learned what is data, what is data, different types of data, what is analytics, what are the different types of analytics, and let's try to understand where is this entire data analytics ecosystem is. First place is your data repository. I saw when we were asking about the questions about data, few of them were telling about repository, right? Data repository is where you store your data. You know what is data? You need to store it somewhere, right? Data repository is a place where you store your data. A simple data repository is a hard disk. your hard disks that is there with you, right? Where you have stored your movies, where you have stored your files, your laptop, which has a hard disk in it, your mobile, where you have your photos, etc. All those are data repositories. Any place where you can store data is called as a data repository. So the first place is the data repository where your data is stored. Then comes the data processing part. From there, you start processing your data. And then it moves to the data analytics, where you do the descriptive analytics, you do the diagnostic, you do the predictive, and then you do the prescriptive. And after that is where you have the business decisions and the business out of it, the revenue out of it, the money, etc. All those comes as the business part. Okay. Now, a data repository to data processing is where your data engineer would be sitting. You might have heard about different terms, right? Different job positions: data engineer, data analyst, data scientist, business analyst, etc. Where does this people sit in this entire ecosystem is what I'm trying to show you. Data engineer is that guy who gets your data from the source, puts it into repository, cleans it, makes it in a good shape, etc., and provides it as a ready-made thing for the processing. That's the person, that's the guy, data engineer, who does this. Okay. From there, it's the data analyst who goes through the data, analyzes it. Sorry, who goes through the data, who analyzes it, makes initial reports, etc. That guy is called as data analyst. Using that data for different types of analytics, like doing a descriptive analytics, doing a diagnostic analytics, trying to forecast what my revenue will be, trying to predict how much business will grow, etc. All that is done by the data scientist. And finally, whatever that you have done in technical terms needs to be converted into business terms. Because when you go to a CEO, they wouldn't appreciate you telling all these technical jargons. They would like to know, what is my business? How much will my business grow? What is the percentage and why do you think so, etc. Those answers needs to be in business terms. That is where your business analyst comes into picture. Okay, see, I'll give you a simple example, and I know many of you might not understand this, and that's the exact reason why I'm telling you this example. A data scientist might come up and tell you that based on my hypothesis testing and my p-value, when I did a t-test based on the hypothesis testing using a t-test, my p and concluding on the p-value, the best decision is to start the shop in Bangalore rather than in Noida. Now, I know that the last part is what made sense to most of you, right? The first part of what is hypothesis testing, what is p-value, what is t-test, etc., are technical things. Now, you need to convert it into business terms. Data scientists would come up with these terms and these results using hypothesis testing as a statistical technique. Okay, and this ties up your data analytics definition using statistics and software, right? So one of the technique is hypothesis testing. You're using certain statistical methods to figure out certain answers. Okay, now if you go to a CEO or a layman telling all these terms, they will tell, I didn't understand a word of you, can explain it better. That is where the business analyst would come and he will tell that, sir, looking into our historical sales in certain areas and in certain areas, we feel that if you start a new shop in Bangalore, we are going to get more sales than if you start a new shop in Noida, because we see the footfalls of people are more here in Bangalore, etc. He tries to convert it into business terms. That is where the business analyst comes into picture. Okay, all good. So the entire ecosystem would look like this: data repository where you have stored your data. From there, the processing happens, and then that data is moved to. Now, again, what is the difference between data analytics and data processing? So I'll give you a simple example and you'll understand one case of what is this data processing. Data cleaning. Okay, you might have see, if someone has a data where there is a column which is supposed to be a mobile number, and in that mobile number, if someone has written ABCD, that is wrong data, right? So that record doesn't hold any value. So we remove that data. Such kind of cleaning, etc., is what is done in your data processing. Okay. So Narendra, what should I repeat? Can you which part? the entire data analytics ecosystem? Okay, I'll just go through the data analytics ecosystem again. Yeah. So you have a data repository where you store the data. Data processing is where you clean, you massage the data, you convert it into the required format, etc. All those things happens in your data processing, and this is done by your data engineer. From there, your initial analysis, reporting, etc. is done by data analyst. When you have to do the different types of analytics, that is where your data scientist comes into picture, and the results that is produced by the data scientist is converted into business terms by the business analyst. Okay. All
Yes,
good?
sir.
Any questions? Friends, in data analysis, mathematics is required. Tough question to answer. I would say yes and no. If you know mathematics, good. If you don't know mathematics and if you know certain tools, it will automatically take care of it. Okay, so it's not mandatory that you should know mathematics. If you know mathematics, it's better for you. Okay. It's like, see, there is a building, okay, and you know that, or you might, everyone knows what is Pythagoras theorem, right? You are this shortest distance kind of attitude, right? You know it, and you know to explain it because you know Pythagoras theorem. Similarly, even if you don't know, by your experience, you know that instead of going through the corners, if I go diagonally, that is going to take lesser time. That is by experience, but you need not know the mathematics behind it. But if you know the mathematics, it becomes easy for you to explain. So there are certain analysis where it becomes easy for you to, for example, the hypothesis testing that I was telling, right? Now, there are hypothesis tests which looks into the variation of the values from the mean. So there are two groups of data with you, your Noida sales, your Bangalore sales. You try to take the mean value and try to check what is the variation. Same thing you do here. If the variation is more in one, it means that there is a problem here. If the variation is very less, it means that on an average, this much sales you are going to get from any location of Bangalore. So how do I know that? Because I know the mathematics behind it. Now, do I really know does someone has to mandatorily know it? No, he can just tell that we did a hypothesis testing. I used this test, and based on that, this is the result. Done. That's enough. So if you know mathematics, it becomes easy for you to explain to people. 10th class mathematics might be slightly not enough. You might need to know more of statistics. I don't know if right now, I graduated way back, so I do not know if the 10th standard right now has statistics in it, like doing your p-value test, all those things. I do not know, but statistics, when I say mathematics, I would mean more towards stats rather than your normal maths. Okay. All right. We'll come to that, Rushikesh. We'll come to that towards the end. Okay. Now, moving on. We learned about three types of data, right? Your structured data, unstructured data, and your semi-structured data. Now, in your structured data, you have rows, columns, etc. Now, where do you store that? Such data is stored in something called as your database. Database is nothing but a repository of data. It provides the functionality for adding, modifying, or querying the data. There are different kind of database store data on the basis of how it is storing the data. Okay, one among them is called as a relational data, where your data is stored in tabular form and has a relation between them. Any software that manages your tabular data which is related to each other is called as RDBMS. So RDBMS is nothing but a software which helps you to control the access of data, organize the data, store the data, query the data, etc. is called as RDBMS. Now, I'll give you a simple analogy for that so that you can understand it better. See, you have your phone, right? And your phone, or you have your laptop where you have stored your images, right? Adobe Photoshop is a software which helps you to enhance that image, do certain Photoshop works, etc. Right? So Adobe Photoshop is nothing but a software that helps you to work on your image. Similarly, RDBMS is nothing but a software which helps you to work on the data. Where is the data stored? The data is stored in your database. How is it stored? It is stored as rows and columns. That's what relational databases are. Okay. And what your RDBMS is? It's nothing but a software. Okay. Next time when someone says, do you know RDBMS? It basically means nothing but a software that helps you to manage the data that is sitting on a relational database. What is relational database? Data stored in a tabular form, rows and columns. A simple example of that is your Excel. But your Excel, if you have seen, if your rows is above certain number, like if you have 10 million rows, etc., your Excel might get it will get stuck, right? It will slow down, it will get stuck, it will shut down, etc., because there is a memory that is attached to Excel, and beyond that, if the data is there, it can't handle it. In such scenarios, we bring in something called as a relational database. Okay. All right. Now, there are different types of databases. You need not by heart it. This is just for your information. One is a commercial one, which is sold by a company. You might have heard about Microsoft. You might have heard about IBM. You might have heard about organizations like Oracle, right? They have built their database and they sell it. Such databases are called as commercial relational databases. Few of the examples are Oracle's database, Microsoft SQL Server, IBM's DB2, etc. Then comes the open source relational databases, which is basically handled by an organization, a non-profit organization called Apache, MySQL, PostgreSQL, SQLite, etc. The benefit of this is for your personal and for your educational purpose, all these open source are free. But when it comes to enterprise level, you will have to pay for the license. But the code which has been used to build these technologies are out there in public. That is why it is called as open source. I know that most of you might know the different open source things that are there outside. Your Uber Linux, and then your Windows is a commercial one, Linux is an open source. You know the difference, right? Similarly, when databases are coming from a certain organization, it is called as commercial one, and when it commercial relational database, when it comes from Apache, it is open source. Okay. Now, the last one is a cloud database, where your database is not in your building. It's somewhere out there and you try to connect it through the internet. And that such databases are called as cloud databases. Some of them are Amazon's DynamoDB, Microsoft Azure's Cosmos DB, and so on. So this is just for information. You need not by heart all this. Someone asks you what are the different, etc. Yeah, the difference, Srishti, the difference between commercial is that you have to pay for it. Open source is for your personal and for a limited use of it. It's free, as well as the code. So for example, how would I give you a simple example? See, if you go out to the web and if you try to download Android, right? Android software, it's available there. And if you know coding, if you know Java, and if you know how to do app development, you can tweak it, right? Because the code is available there in public. That is where it's called as open source. The code is available to you in public. You can tweak it, you can make changes, and you can customize it. Whereas, I don't know if you might have used, okay, Apple. You won't see Apple iOS software anywhere. You won't be able to download it. You won't be able to tweak it. Apple will give you, they will tweak it and give you. That's the only way. So it's a closed one. It's a commercial one. That's the difference between your commercial and open source. And that rule applies everywhere. Be it your relational database, be it your mobile software, be it your anything out there. That's what the difference between commercial and open source is. Now, next one. So now you know that. So I hope you are getting that flow and the story here. We learned about data. We learned about different types of data. We learned about data analytics. From there, we took one type of data, which is your structured data. We understood where this can be stored, how this can be managed. RDBMS helps you to do that. Now, the next one is, yes, we are good. We know how to store your data, but how will I use that data? How will I figure out what is happening to my business? How will I able to figure out what was my sales by looking into that data that is sitting in my database? That is where you are introduced to a new language which is called as SQL, which can be pronounced as SQL, which stands as short form for structured query language. Now, very easy to remember. What are we dealing with? Structured data. Now, what do you want to do? I want to query. I want to query into it. I want to ask questions to the data and get answers to it. So a language that helps you to query the structured data is called as SQL, or structured query language, SQL. Okay. It's used for relational databases. Obviously, where there's rows and columns, that is where you use SQL. There are different types of SQL statements. Now, your SQL, I don't know, most of you might be aware of the different programming languages that are out there, right? Your Python, your R, etc. SQL is nothing but another language which helps you to query the structured data. So it's nothing but again a programming language. So that language is called as SQL, structured query language. And there are different types of SQL statements, which is the first one is the DDL. DDL stands for data definition language. This is where you might have seen tables, you might have heard about tables, right? DDL are those type of SQL statements which will help you to define a table, telling that, hey, my data set will have 10 columns. The first column's name is name, and it is a text field. The second column's name is ID, it is a number. The third column's name is phone number, which is again a number. It will have only numbers, etc. You are trying to define it. You are telling that my first column is this, second column is this, third column is this. So SQL command or a statement that helps you to define a table, define the schema, change that or delete that is called as DDL, data definition language. The DDLs that is present in SQL is create a table, alter the table. You have created a table, you want to make a change to that. That command is called as alter. If you want to delete the data that is there in that table, you use truncate. If you want to drop that table altogether, the name is self-explanatory. Create is for creating the table. Alter is to alter the table. Truncate. Truncate means your column names would be there, but whatever data that is there is deleted. That is what truncate is. Drop means including the column name, the entire thing is deleted. That is what drop is. So the first type of statement is DDL. Then comes DML. DML stands for data manipulation language. Now, DDL helps you to arrange your data. It still doesn't give you answers for your questions on how was my sales, on particular day, what was my sales, on a particular location, what was my sales. It doesn't answer you. If you want to get answers from the data, that is where you use DML. Some of the most common ones are insert, select, update, delete. Insert means if you want to insert one more row into your data, you use the insert statement. Select means if you want to particularly select one row and understand what are the values, you use the selector. If you want to update a value in a particular column, you use update. If you want to delete a row as such, you use the delete. So SQL is nothing but structured query language. It is used to analyze, SQL, it is used to talk with your database. There are two types of statements, DDL and DML. Okay, DDL, create, alter, truncate, drop. DML, insert, select, update, and delete. Okay, see you can go into the details of this and then understand each one of this. Since this is an overview, I'm just touching only on these points, so that you can go and understand and learn it from you. Okay, if I try to take it into detail, this will take more time. Okay, so that's why I'm only touching the basics. And I see one of the comment that W3 schools, there are many of them, okay, which is W3 schools, SQL Shack, etc., where you can go and learn the SQL. Okay, but the point here is, why do we need SQL? Because you have data in your databases. What data is there in your database? Structured data. Okay, what is structured data? There are three different types of data: structured, semi-structured, and unstructured. Okay, then what is data? This is what data is. Why do you want to do all this? Because I want to do analytics. Okay, what is analytics? You know what is analytics. Okay, what are the different types of analytics? You know what that is. So I hope you are getting that entire picture. So that's where the connection comes. Okay, now SQL. Any questions on this? I know this is a bit technical, but the difference between truncate, Srishti, the difference between truncate and delete is, truncate, when you run a truncate command, your entire rows, let's say that you had a table with 100 rows. You say that truncate that table, your 100 rows is deleted. Whereas if you want to delete only the 75th row, you use delete. You pick and delete, you use delete command. If you want to delete all the rows, then you use truncate. Now, the next question that might come to your mind is, if I don't want to pick, if I use delete without any condition of 75th column, I tell that delete all rows, isn't it equivalent to truncate? Yes, practically it is equivalent, but technically there is a difference. I do not want you to go through to that technically, because your truncate data is faster, whereas delete is slower. Your truncate data can be rolled back, whereas your delete rollback takes time, etc. So there are some technical differences, but practically, if there is no condition put for your delete statement, it deletes all the row, it is equivalent to truncate. Truncate cannot have a specific condition. The moment you tell truncate the table, all the rows gets deleted. Okay. Did I answer your question? Okay. I hope yes. Fine. Now, moving on. Next one. So in your select statement, there are certain functions that you can read and understand about, like count, distinct, limit, etc. I'll just touch it on. I won't be showing you examples. You will have to go and do it for yourself, because that, again, as I told, will be a detailed session. What does count do is, when you run a count function on your select statement, it will tell you how many rows are there in your entire data set. For example, if there is a table called customers, which has the details of customers in it, if I do select count star from customer table, it will tell you how many rows are there in that particular table. Distinct means, if you give a column name, someone is on, can everyone go on mute, please? Select distinct means, if let's say that there is a column and it has the customer names, okay, and you want to know what are the different names that are there, the unique names, that is where you use distinct. Now, let's say you want to see how the data is looking. You do not want to see the entire data, but a few samples set out of it. You use the limit function. Limit 10 rows. Select or star from table. Limit 10 means it will take the first 10 rows and show you, so that you get a hang of, okay, this is what this column has. These are the columns. This is the value that is there in the column, etc. Where is equivalent to your filter conditions. You are telling that I need data where my location is Bangalore. So select star from table where location equal to Bangalore. What your RDBMS does is, it goes into the table, looks for the data, and returns only that information where your location is Bangalore. So that where is equivalent to a filtering. You're filtering the data and seeing. Now, in your filtering, you can use different conditions. It could be like my location, or if customer name like Mike. So it will give you customers whose name are Mike, Mike Stan, or Mike Robert, or Mike Jackson, etc. Everywhere, anywhere you see Mike, it will pull that. So like will try to match it. Another scenario is where you want to see the records between so and so condition, telling that I want to see the records where the sales date is between 1st of July and 2nd of July, etc. So between condition is there, like condition is there. If you want to club two conditions and both conditions should be satisfied, then you have and. If you have more than one condition and only one of these condition needs to be satisfied, or all these are your basic things that you might have learned in your 11th, right? In your +1, which is that sets, joins. If you remember, there was a lesson, right? In maths, sets, joins, where you had these two circles and then you were learning all those things, and, or, in, etc. Same thing. Order by is where if you want to see the results in sorted order, it could be by a column in ascending or descending order. Group by is where you are trying to group your records and trying to do certain functions on top of it. I'll give you an example. Let's say that you have the sales data of different locations in India, Mumbai, Delhi, Bangalore, Chennai, etc. And you want to see for each location, what are my sales? What is my total sales? So what you will do is you will tell RDBMS to group your data on the basis of location. So what RDBMS will do is it will take all the records of Chennai together, all the records of Delhi together, all the records of Mumbai together. And then you will tell that find my sum of sales, total sales. So it will take that group, sum up the sales and tell that for Chennai, this is the sum. For Mumbai, this is the sum. For Delhi, this is the sum. Group by a certain column and do a function on top of that. That is what the group by does for you. Okay. The difference between, okay, before that, by mistake, I've changed the data or delete data. So how can I undo the change or delete? Okay, it depends on which database you're working on. So certain databases, so there is a command called as commit. Okay. When you make a change to a table or when you delete the data, in certain databases, it's auto commit. It means that once when you commit it, you can't do anything. It's committed forever. Certain databases, you will have to manually run the commit command. If unless and until the commit command is done, it is not saved permanently. It's not persistent. So you can always roll back. Now, in certain databases, there is something called as the checkpoint concept. What it does is it keeps a copy of the existing DB. It keeps an image of the DB at a certain time. So even if you have committed after that, you can roll back to that checkpoint. So it depends on the type of database that you're using. Certain databases helps you to roll back. Certain databases, which is auto commit, if there is a checkpoint, you can roll back to that checkpoint, etc. Okay. Now, Srishti, the difference between limit and distinct is, let's say that you have a table with 10 million rows. Okay. Now you want to know how many columns are there, what are the columns, what are the values in it. If you try to fetch the entire 10 million rows, it will take some time, right? You do not want to see the entire data. I just want to see what are the different columns, what are the values, etc. So for that, you can just fetch one row and then see all these things, right? Such scenarios where you just want to fetch a single row or limited number of rows, first 10 rows, etc. You use the limit function. Select star from table, limit 10 means it will fetch the first 10 rows from the table. Distinct means, let's say that there is a column in your table. Okay. It has different, it's a customer name. Okay. Now, one customer's name is, his first name is Mike and second name is George. Second customer's name is Mike and his second name is Joseph. Third name is John, surname is Doe, etc. Now, if you see your first and second row, your first names are same, correct? Mike. Now, when I run a select distinct on first name, it will just pick one mic out of the two mics that are there, because it's trying to give you the unique values that is present in a particular column. That is what distinct is. Distinct means the unique different values present. Limit means it will take the first certain number of rows and shows you. That's what it is. Okay. All right. Now, Other set of built-in functions are sum. If you want to sum up the values in a column, you use sum function. In a column, if you want to find out which is the minimum value, which is the maximum value, you use min max. If you want to find the average, use the average. If there is a text column and you want to find the length, the number of characters in that text, you use the length. If there is a number, you want to round it off to the next integer, you use round function. If a text is in low, if it is in small letters, if you want to make everything in uppercase, you use upper, or in certain database, it is U case. If you want to make it lowercase, you use lower or L case. If you want to get, if there is a timestamp, there is a date with time, etc., but you just want the date out of it, you use the date function. If you want to get the entire time, you use the time. If you want to get both date and time, you use date time, etc. So these are all built-in functionalities of SQL that will help you to make it easier to work with the data. This is all for your understanding, but when you become serious about learning this, you will get to understand what is the use, what is the benefit, etc. of this. I'm just giving you a hang of all these things. Okay. Next one is the sets and joins. This was what I was trying to tell you. You might have seen this, your Cartesian circles, you might have learned there, right, in your plus. So set is union. These functions are also available in your SQL, where you have union, you have intersect, you have except, you have union all, etc. Let's say that you have two sets of data A and data set B. Okay. Union means data A arranged after that data B. This is like, let's say your data set A has 10 columns and it has 100 rows. Your data set B has 300 rows and the same 10 columns. A union B will give you 400 rows. All with me, 100 rows and 300 rows. A union B will give me 400 rows. Intersect means whatever that is common in data set A and data set B will be shown to you. Let's say that out of that 100 rows in A, 50 rows are also there in your 300 row data set B, then intersect will give you that 50 rows. What is common between two data set? Except means whatever that is present only in one data set. Data set A except data set B means whatever that is exclusively there in A will come out. Union all means when union is run, if there are any records that are present in both data set, it will choose only one of that. So for example, your first data set has 100 rows, your second data set has 300 rows. Let's say the 10 rows that are there in data set A is common to 10 rows in data set B. Then when you do A union B, you will get only 390 rows because your 10 rows are common in both. It will take only one set of that 10 rows and show it. Whereas union all will also show that duplicates, which means that A union all B will give you 400 rows, whereas A union B will give you only 390 rows, where 10 rows is common between A and B. A intersection B will show only those 10 rows. A except B will give you 90 rows because those 90 rows that is there in A is not there in B. That is what A except B is. Now, join. Join is a different concept. Here, when you have to do these set operations, one thing that you have to remember is the number of columns and the column types. Everything should be same for both the data set. You can't have a data set with 10 columns in one data set and 20 columns in another data set. It will not work. Now, in such scenarios where you have two tables where you have different number of columns and you want to figure out which are the common ones, which are not there, which is the total one, etc., that is where you come up across the join condition. Table 1, inner join table 2 will give you the common part of table 1 and table 2. What are the rows that are common in table 1 and table 2? Now, you might be thinking, what is the difference between intersect and inner join? In intersect, your number of columns have to be equal in both data set, whereas in join, the number of columns need not be same. Left join, it will give you all the common as well as what is there in your table 1. Again, the ulta part of it is right join, it will give you what is the common as well as what is there in table 2. Full outer join will give you the common ones as well as what is there in table 1 and table 2. Now, the question that might come to you is, see, why do we have to do a left join? Because all I have to do is fetch the data in table 1, right? That is what is coming up here. No, the difference is, along with table 1's data, you are fetching the columns that are available in table 2 also. So let's say that your first table had 10 columns, your second table had 5 columns. Table A left join table 2 will have 15 columns. Okay, that is the difference between your, whereas if you just fetch table 1, it will give you only 10 columns. It will not give you the corresponding values of the 5 columns in table 2. This is what the join is. Okay, so set, union, intersect, except, union all, join, inner join, left join, right join, full outer join. Again, these are things that you have to learn in detail. As one of the participants suggested, W3 or SQL Shack is where we should go. In detail, they explain what are the differences, etc. But these are the basic concept that you have to learn when it comes to SQL. Now, where does data science sit in all of these? Okay, so the entire picture is, this is where, when the entire artificial intelligence acts as the outer shell. Machine learning is a subset of your artificial intelligence, and you might have heard about deep learning, etc. Right? One type of machine learning is deep learning, and then when all these combines with mathematics, statistics, visualization, EDA, etc., that is where you call it as data science. So artificial intelligence is nothing but a technique which enables machine to mimic human behavior. One of the type of artificial intelligence is machine learning, where you use statistical methods to enable machines to improve the experience. Now, one type of machine learning is your deep learning, where you use a technology called as the neural networks. All of this is combined with your mathematics and statistics, and that area where all these come together, where you use all these AI techniques, ML techniques, or DL techniques, and it involves mathematics, statistics, visualization, EDA, etc. It's called as data science. Okay. Srishti, union all is where there is even the duplicate items are shown. Okay. For example, your data set A has 100 rows. Dataset B has 200 rows. Out of these, 50 rows are same. Okay. A union B will give you 100 plus 150. That is 250, because 50 are common. Whereas union all will not consider about duplication. It will give you 100 plus 200, 300 rows. So your same row the 50 rows will come 2 times. Whereas union, 50 rows will come only once. Okay, that's the difference. Okay, coming back. So you know what is AI, data science, and etc. Now, Python and SQL. So as you know that most of your machine learning things are working, most of the codes are written in Python, because it's very easy to learn and there is a huge community out there. There are hundreds of Python libraries and frameworks. I'm pretty sure that anyone who is trying to become a data analyst or anyone who is trying to learn might have got the advice that you study about Python, etc. Right? Because the reason is because it's very easy to learn and it's very popular as well. Now, some of the Python libraries that are available there is the scikit-learn, Keras, TensorFlow, etc. You might have heard all these. Now, this Python has an inbuilt support for SQL, which basically means that in your Python program itself, you can write SQL statements and then fire query against the databases like SQLite, MySQL, Oracle, etc. Which basically means that if you know SQL and if there is a machine learning code which is written in Python and your data is sitting in a database, inside your Python code itself, you can write SQL which will connect to the database and fetch it for you. So this makes it a holistic package, which means that you need not go to a database, fetch the data, put it in a file, and then feed it to Python. No. In your Python itself, you have your APIs which will connect to your database and fetch it directly, and everything will be handled there itself. You do not have to do any outside work. That is the support that is the SQL support that is there in Python. Now, why did I bring this into the picture? Almost 90% of your ML models that are running right now are written in Python. And there is a huge set of data that is there sitting in your databases. How can you bring in those together? Using the SQL support in Python. Now, after all these technical things that we have learned, what is really important is you should know how to work through a problem from beginning to end. It basically means that you should understand what the business needs before doing the data analysis. For example, if you remember the example that I told of going from A to B, route 1 and route 2, the question that you need to ask the business is whether you want to reach early or whether you want to reach at a cheaper cost, right? So you should know what the business needs and then try to do the analysis and then try to answer the question. Next one is you should understand what data that what is the data that you have, how many columns are there, what this particular column means, could it have this value, could it have that value, etc. Now, using SQL for data science is usually extracting the data from one storage system, analyzing it, and then maybe writing back for a prediction to the database. So where does SQL sit is you can pull the data from a database, do certain analysis on top of it, provide it to your ML model so that the predictions can be done further. Okay. And usually the entire system is based on a question or a type of analysis that we are doing. For example, how can I reach early? How can I reach with lesser cost, etc. So the entire business problem acts as the center. From that business problem, you try to understand what the business needs. Based on that, you do the data analysis. Your data might be in SQL, etc. You manipulate it and then you do give it for further insights or prediction. So it's always important, irrespective of your expertise in tool or irrespective of I've seen many people who tell that I'm very good in Excel, I'm very good in SQL, I'm very good in Python. But unless and until they do not have that capability to understand what the business problem is, what is it that we are trying to solve, everything is of no use. Okay. So always make sure that you first understand what is the problem, what are we trying to solve, and then come with the analysis, right? So one question that was asked earlier was which is the best analysis tool, right? Data analysis tool. This is where I told there is no answer for that because it depends on what you are analyzing, what your problem is, what is your data. Based on the data, based on the problem, you choose the tool also. If it is structured data, you choose SQL. If it is unstructured data, SQL doesn't hold any good there. If it is a PDF, you can't put it into an Excel and then analyze it, right? So that's what it depends on what is the data in your hand, what is the problem at hand, and then you try to solve it. So that is the important point. Next steps. I've touched through the basic parts. What you can do is you can learn more about things like subqueries, where you write query within a query. It is also called as inner query. There are different types of subqueries. You can go through all those things, try to understand that. Then there is something called as a regular expression. It is used for searching. You might have learned this regular expression in other languages also. The same concept is present here as well. Then there is something called as a window function, which helps you to rank your data, which helps you to figure out a cumulative sum difference between previous day and current day sales, etc. Lead lag function, first value, last value. There are things like window function. These are all advanced level. Okay. So once when you are thorough with your DDLs and DMLs, the different functions, your different joins, your different set operators, etc., you should move to the concept of subqueries, regular expressions, window functions, etc. That's all for today. I know that there has been, towards the end, there was a lot of things that was covered technically, but the point that you have to remember here is why we are doing all these things. Okay. I always try to give that context to the audience so that it makes them understand that this is the reason why I'm learning this. You have data. In that data, there is a type of data called structured data. And this structured data is required for your analytics. This structured data sits in a database. If you need to learn about, or if you want to understand that data sitting in your database, I need to learn about SQL. In SQL, I have DDL, DML. I have certain functions like sum, average, built-in functions, etc. Then I can do more operations like set operations or join operations. Beyond that, again, if there is something complex I have to achieve, I can use it using subqueries, window functions, etc. Now, where does it all sit? After all these, I can use this data, push it to an ML model to do the predictions so that I can do prescriptive analytics, so that I can make better decisions for my business. This is the entire picture. Okay. Know that we went slightly overboard. Any questions? Any questions?
Thank you so much, Mary. Thank you for your time. I mean, while you went slightly overboard, but it was still an engaging and a very thoughtful session because we still have more than half of the participants on the call. So that's a good sign. And also, I've shared the feedback form on the chat box just in case you guys want to give a feedback, and also a link to all the sessions that has been recorded where you can register and get your recorded sessions. Yeah. So Padmavati, just to answer your question, I've shared a link, Apna Exclusives link on the chat box where you can register yourself and get access to all the recordings over the last few weeks. All right. So thank you, everyone. Thank you again for joining. Thank you, Mary. Thank you for taking
Thank you.
time
Thank you
out
all.
on a
Have a
Sunday.
great.
Thank you
Have
so
a
much.
great.